Example problem 7-5. A linear actuator is used to push a load leftward. Starting at rest, it requires 1.5 seconds to reach a full speed of 0.75 meters per second. Determine the linear acceleration of the load. Also determine the linear displacement of the load during this acceleration phase of motion. Alright, so let's write out our known. So we know that V naught is equal to 0 meters per second, as we know it's starting at rest. We know that V1 is equal to 0.75 meters per second. We also know that T naught is 0 and T1 is equal to 1.5 seconds. Okay, so it says we have constant acceleration, so we can use the generic formula for acceleration. Acceleration is equal to the change in velocity over the change in time. So with this, we go from 0 to 0.75 meters per second in 1.5 seconds. And that gives us an acceleration, a linear acceleration equal to 0.5 meters per second squared. So this is our constant acceleration as the linear actuator increases from 0 to 7.5 to 0.75 rather meters per second. All right, now let's find the overall displacement. So we can use formula. Displacement is equal to V naught times T plus 1/2 a T squared. So displacement is equal to 0 times 1.5 plus 1/2 times our acceleration of 0.5 meters per second squared multiplied by our time squared, which is 1.5 seconds squared. And this gives us a total displacement of 0.5625 meters. And now remember, this displacement is from when the linear actuator starts pushing the load leftward to when the load reaches 0.75 meters per second. So this is the displacement over 1.5 seconds of motion.